Good morning, students. So this is a continuous session of the arrays. So this will be the second session in which we discuss multi-dimensional arrays. So often there is a need to store and manipulate multi-dimensional data structures such as matrices and tables. In that case, we generally use the multi-dimensional array. In multi-dimensional arrays, we will discuss mostly the two-dimensional arrays. So in two-dimensional arrays, basically we have two scripts, subscripts based. One is used for rows and another is for column. So how to declare a two-dimensional array? First there will be a data type, then there will be an array name, then row, then column. For example, int m1020. Here what I am doing is I am declaring a 2D arrays whose name will be m of type integer having rows 10 and column 20. So just like a single dimensional array, the index of two-dimensional arrays also starts from 0. So the rows will be from 0 to 9 and the columns will be from 0 to 19. So the first element of the matrix will be M00 and the last will be M9 and 19. Okay, now let's discuss the memory layout of two-dimensional array. So as you remember that the arrays are stored as a continuous memory allocation. So that means all the elements are be stored at in the continuous location. So in two-dimensional array, let's have a one array as marks in which having a 2 rows and 5 columns, which is of a integer type. So how many elements will be there? 2 into 5, there will be 10 elements. So how memory location will be placed? So there will be 10 elements in the continuous memory location, and the first element will start with 100, second 102, third 104, sixth 106, and so on. So that element first will be represented by M00. That means row will be 0, column will be 0. Second will be M01. That is row will be 0, column will be 1. Similarly, if I say M10, what does it mean? It means that it is having a second row and first column. So now let's discuss how to initialize an arrays. There are a couple of ways to initialize the array. The most general way of initializing it, provide the number of elements here. Like int marks 3, 2 is equal to 1, 2, 3, 4, 5, 6. So that means here I am declaring a two-dimensional array of having rows 3, column 2. And the value will be 1, 2, 3, 4, 5, 6. That means 0 element will have 1, 1 element will have 2, then similarly the others. The second way is provide them in pairs, that is 1, 2 closed in a curly braces, 3, 4 and 5, 6. And third way is we are not providing the row but we are providing only the column. So in this example what I am doing is I am saying int marks, then the row is blank and we have a column of 3 and the elements are 1, 2, 3, 4, 5, 6. So it will create an array, 2D array with columns 3 and number rows will be 2. Similarly, let's discuss these two notations. In it we have int marks, row is there but column is blank. This is not allowed, it will throw an error. So column is mandatory one. And the next one is having both column and row are blank, it's again throw you an error. So accessing the elements of an array. Just like in a one-dimensional array, two-dimensional array elements are accessed using the row number and column number. Like row script and column script. For example, my array 2, 3. That means I am accessing an element of row 3rd and column 4. So now let's discuss practically how to create an array, how to insert the elements into array and how to display the. So let's create first an array, say of 3 row and 3 column. Now let's say I provide row is equal to, I take a variable in which I say row is equal to 3 int. You can take row and column from user also, but for simplicity, I am setting rows and column as a constant value 3 and 3. So let's create another variable I is equal to 0. Okay. To input the elements of an array, we use two loops for two-dimensional arrays. Let's see how. First loop will represent is used for the row and second loop will be used for the columns. So here I is basically for the row. I say I is equal to 0 and the I will be less than 3 I plus plus. Then one another row j is equal to 0, j less than 3. For more clarity, let's print a message. I will show how it works. First, write a program. Now, this is the important part. Now we have an array name array. Now the element will be entered based upon the script. Here it will be I and will be J. So this is how we basically enter the elements. Let's display it also. Same way we will display the elements. So now what we need to do is we need to print the elements. The name of array is let's run it. Rows 3, columns. And so it enter the element 0, 0. So I say 1, 0 to 2, 3, 4, 5, 6, 7, 8. Okay. So you can see that we have entered the element 1, 2, 3, 4, 5, 6, 7, 8 and the elements. Okay, now let's discuss the second program. That is write a program to add two square matrices. So I hope you know how to add two matrices. So corresponding elements of the each matrix will be added. For example, let's see here. If I have matrices 1, 2, 3, 4, 5, 6, then 7, 8, 9. This is first matrix. Second matrix says 2, 4, 6, and 1, 2, 3, say 6, 7, 8. So I have a two matrices, this. So if I want to add the matrices, that means this one will be added with this 2 will be added with 4, the 3 will be added. That is corresponding element will be added. So let's write a program to add two matrices. So first array will be say array 1, 3 equals this. Then I say let's take array second as array 2. Then I need to store the result. I say result matrices result array 3 will be 3 comma 3. Row will be 3. So same way we will enter the elements of an array. This is array 1. Now I need to enter the elements of array 2. Just copy this. Let's write some messages. Please enter the element of first array. Here let's display message element of second. Now what we need to do is we need to add it. Same way we will have two loops. One is for row, one and column. Then we need to add the corresponding elements and store in the result. We have taken result, right? Yes. So result I comma j will be equal to what? Array 1 I comma j plus array 2 I comma j. So we are done. So when loop will run, first value of I will be 0 and value of j will be 0. That means 0 0 result will store 0 0 and 0 out of this added. Then there will be increment of this loop because there is a nesting of loops are there. So j will be incremented. It becomes 1. It becomes 1. It becomes 1. Again it will be incremented. Okay, so now let's display the results. Same way we will have two loops display the array. The result is stored in this. Then display a new line after each row. Okay. So this is a program. Let's go again to understand this. What I have done is I have created a two arrays, array 1 and array 2. Both are having size 3 rows and 3 columns. Then I need to store the result of their sum in third array. Then I have taken result 3 of same dimension 3 comma 3. Then I have taken row which is a 3, so I put it 3, column 3, then there is a subscript 0 0. So now first we need to enter the elements. So there will be two nesting loop. First loop will be for rows, second loop will be for columns. So let's use row here for more clarity. So to enter the elements, I enter the element, then I need to enter the second element. Same, let's do it. Then here I'm adding it. Then I'm here displaying it. Okay. So let's make it two-dimensional too, so that it is more easy to understand. Let's also display both the arrays so that we know how adding shoes. Display the array 1. So here I will put array 1. Here will be array 2. This is the result. Okay, let's again go through it. This code will basically use to insert first elements of array. This we use to insert the second elements of an array. This will add two arrays. Display array 1. It will display array 2 and it will display the result. Let's save it and run it. Compile and run. Enter the element, first array element 0 0, say 1, 2, 3, 4. Enter the element second and let's say 5, 6, 7, 8. So this is the result. 1, 2, 3, 4. 5, 6, 7 result is this. Okay, let's add some message so that we know that this is the result. Let's again run it. So 1, 2, 3, 4. Second is say 5, 6, 7, 8. So the first element we enter is 1, 2, 3, 4. That is for array 5, 6, 7. Let's add it. 1 plus 4, 6. Result is here. Then it's 2 plus 6, 8. Then 3 plus 7, 10. So this is this. So it's working fine. So this is a program to add two arrays. So let's move to the next one. Next one is write a program to find a transpose of a matrices. So I hope you understand what the transpose of the matrix is. If not, let's see what is transpose. Let us suppose I have a matrices 1, 2, 3, 4, 5, 6, 7, 8, 9. The transpose will be interchanging the rows with the column. So the transpose of the above will be 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's now create the program for the transpose of the matrices. Again, what we need to do is, okay, let me delete all this program. No, I don't need these two arrays. I just need the result. Let's name it transpose. Okay, let's take it. Okay, let it 3 by 3. So enter the element of the array will be the same method. Now we need to find the transpose of them. So again there are two loops. Int I is equal to 0, I less than rows I plus plus. Similarly we have for j is equal to 0, j less than column j plus plus. Then I need to do the transpose, and the result will be stored in which matrices? Transpose. So in a transpose, what we do is we basically change the row into column. So here what will I do is I j will be equal to what? Array 1 ji. I hope it's clear. What I'm doing, we are just need to reverse it. That's all. Let's display it. Let me copy that. This will be very easy to do. Okay, let's run it. I have to close this. One, two, three. See what happens. It has to be percentage %d. And let's display the array also. Let's display the first matrices also. One, two, three, four, five, six, 7, 8, 9. So this is the resultant. Can we see that? 1, 2, 3, 4, 5, 6, 7, 8. This. So let's display one message here. Okay. So the original matrix what we enter is 1, 2, 3, 4, 5, 6, 7, and 9. And the transpose is this. So how I hope you understand that. So okay. So next program is write a program to check whether matrix is symmetric matrix or not. Okay, first understand what is a symmetric matrices. A symmetric matrix is those matrices whose transpose is equal to original matrices. So let's create a program for the same. So we have already created a program to find out the symmetric matrices. Now let's compare this with the original matrix. So again, we need to have two loops. One will be less than rows. Another will be less than column. Now what we need to do is we need to compare the each element of two matrices. The first matrix is array 1. Each element, that means we will compare it with the indexes. So when the element is not equal to this, so now what we need to do? If the element is not equal, that is matrix is not transpose matrices, so print a message here. Then what we need to do? Do we need to check the other elements? No, because if one of the element is not matching, that means it's not matrices. So we need to come out of the loop. So how we come out of the loop? We use a break statement. I hope you remember that. So is this break statement is good enough? So break statement, what it do is it breaks the inner loop. I mean, say existing loop. Here the loop is this one. So it will break from the this loop only. So what about this one? We need to break from this loop. Do we use the two break statements? No, we cannot use that. So what will be the solution? So what we will do is we create a variable, say is symmetric is equal to 1. That means we presume that matrix is already symmetric. So we use that condition here. If row is less than this and matrix is symmetric, then we will come into this loop. I hope you are understanding that. So we are presuming initially that matrix is symmetric matrices. Now, if I is less than row and symmetric matrices, then we need to enter into the loop. So once elements are not matching, then what we need to do is we need to set this as a 0. That is matrix is not symmetric. So we are assuming that if I symmetry is 0, that is matrix is not symmetric. If I1 is equal to 1, matrix is symmetric. So how it will work is when element one of the element is not equal, we will print matrix is not symmetric. Then we set this is equal to 0. Then we break. This break will break this loop. Then it come into this loop. In this loop, I is less than rows. Yes. Is this equal to 0? Is equal to 1? No, because we have already set it as a 0. So this loop will also terminate. Now we need to print whether it is a symmetric or not symmetric, because we already printed matrix not symmetric. So how will print matrix symmetric? If this is still 1, that means matrix is symmetric. So this is also a same program to compare two matrices whether they are equal or not. So let's understand again. What we are doing is we are assuming that matrix is already symmetric by declaring a where ISIS and we are putting it as a 1. If its value is 1, we will assume the matrix symmetric. Then we are using two loops. One loop is for row. So here condition we are using two conditions. One is if it is less than row and matrix is symmetric, then we will execute it. Then inner loop, what we are doing is if any of the element is not equal, then we print matrix not symmetric and we will set this as a 0. Then we'll break. This break will break this inner loop, but this break will not break the outer loop. To break the outer loop, we are using this condition. So how we'll check whether matrix is symmetric? If this value is not 0, then that means I is still 1, the matrix. Let's execute this. It says this. Why there is an error? Okay, I'm using this. Not should not be there. Okay. Okay, let me enter 1, 2, 3, 4, 5, 6, 7, 8, 9. So see, this is matrix we initially enter 1, 2, 3, 4, 5, 6, 7. It transposes 1, 2, 3. Is this equal? No. So the answer is matrix is not a symmetric matrices. So let's run one symmetric matrices example. Every diagonal matrix is a symmetric matrix. Let's enter one diagonal matrix 1, 0, 0. Then it will be 0, 1, 0. Then it will be 0, 0, 1. So you can see that the matrix I enter is 1, 0, 0, 0, 1, 1, 0, 1, 1, and its transpose same. So it shows that you can see the matrix symmetric. So this is the program to check whether a matrix is symmetric or not, and this logic is also for the program to check whether two matrices are equal or. I hope you understand that. So let's move to the next program. Okay. Next is write a program to multiply two square matrices. Okay. This is a very important program for even for the purpose of examination. So let's first understand what is how we do the matrix multiplication. Okay. Let's suppose we are having a two matrices, square matrices of order 3 into 3, that is 1, 2, 3, 4, 5, 6, 7, 8, 9. The second matrix is 10, 11, 12, 13, 14, 15, 16, 17, 18. So how matrix multiplication will work is first this element will be multiplied by this, then plus this will be multiplied by this, plus this will be multiplied by this. So this will be 1, 1. Similarly this and this. And the answer will be like this. So let's understand the logic. This is a little bit complex logic. Let's try to understand it. There in this program we will be using a nesting loops as we are always using it, but here we are going to use the three loops. First loop will be for number of rows, second will be for number of columns, and third loop will be used for the actual multiplication, and that loop will be compared with the columns. Let's do it practically. Okay, we don't need anything here. We need two matrices. Let's say array 1 and array 2 are the two matrices. Then what we need to do is we need to enter the element. This will enter the first element. Let's copy this code to enter the second element of the matrices. Let's copy it. Print, please enter the elements of sec. in array. Let me read the first array slash m here. And this will be array 2. Okay, now I need to rewrite a actual multiplication. So we need a 3 loops here. One will be for rows, one will be for column, and we will use a third loop. We don't need it. We don't need this. We haven't taken the third matrices. Let's take the third result where we will store the result of the matrices. Excuse me. Okay. For we will take a variable for third. Let's say it k, which is equal to 0. This is used for actual multiplication. K is equal to 0. K less than will be column. So as discussed, we will have 3 loops. One loop will be compared with the rows. Second loop J will be compared with the column. And third loop K will be compared with the column again. Then K plus plus. Here we do the actual multiplication. So where we will store the multiplication? We will store the multiplication result. So result, again the each element ij will be equal to, if you understand the matrix multiplication, previous result will be added to this plus what here we need to do is you need to concentrate on this. First array 1, then its ith element, then its k element will be multiplied by array 2's k element into j. So this is the array multiplication. So again, let's see, result ij will be equal to result ij because we need to add the previous one plus multiplication of array 1 ik into array 2 k. Just look into this statement. This statement will actually do the array multiplication. So after that, let's display the arrays. We are already displaying here is array 1. Let's display the array 2 also. We are displaying it already there. Now we need to display the actual array multiplication. Don't need this code. Array multiplication was stored in a result. Let's change the message in the matrix. Multiplication of this thus is so now let's again understand the program. So we have taken two arrays, array 1 and array 2, both of them having 3 into 3 dimensions. Result will be stored into 3 into 3 dimensions. So we have taken one variable, number of rows is 3, column, then we have it subscripts I and j. Then first we need to enter the first element. How we are doing in second dimensional arrays? One loop will be for rows, one loop will be for columns. Then we will store the element to I. Then we need to enter a second element same. Here we are doing array 1, here we will do the array 2. Then we need to do the actual array multiplication. Here in actual array multiplication, we will take the 3 loops. One loop will be for row, one loop will be for column, and this third loop will be used for actual multiplication. And this third loop will be less than equal to column. So where we say result ij, because the element will be ij, is equal to result ij, because we need to add the previous one, plus this is actual array multiplication. Array 1 I into k multiplied by array 2 k into j. Then we are displaying the first matrices here. Then we are displaying the second matrices here. Then we are displaying the result matrices. Okay. So let's do one thing. Initialize the result array elements to 0. So let's run it now. 1, 2, 3, 4, 5, 6, 7, 8, 9, say 10, 11, 12, 13, 14, 15, 16, 17, 18. So the first matrix is 1, 2, 3, 4, 5, 6, 7, 8, 9. Second is 10, 11, 12, 13, 14, 15, 16, 17, 18. And resultant is 84, 90, 96. Let's verify that I have the answer with me. 84, 90, 96. 84, 90, 96, 20, 1, 2, 1, 6, 2, 0, 1, 2, 1. Okay, so the result is 5. So this is all about the matrix multiplication. So I hope you understand that. Thank you.